So, good day, everyone. We're here to explore structured query language or SQL. And as MSIT students, understanding SQL is crucial for data management and data sciences. So, for most of you who have background with SQL already, I believe this is just a review of this context. And I hope the same that you'd be able to help us go through with the concepts I would like to share in here, as much as our colleagues in this session may have a little background about SQLs. So we'll see SQL as the foundational tool for relational database systems. And with the with building from our last discussion, let's connect SQL to advanced database management. We are able to explore at the end of this session uh, relational database management systems, how data structures into tables, and how relationships are formed. So SQL is a universal language for these systems. Uh, it lets us define, manipulate, and control data, ensuring integrity and security. So this standardization makes SQL incredibly powerful, allowing us to work across various database platforms with consistent skills. So this sets a stage for understanding SQL's core role. Next, we'll delve into the specific functions SQL actually performs. At its heart, SQL is a powerful declarative language. It's not just for querying, but it's a comprehensive tool for managing data. SQL allows us to retrieve data, to manipulate existing data, define database structures, and control access. In today's data-driven world, SQL is indispensable. It powers data-driven decision-making from business intelligence to back-end operations. Without SQL, managing vast amounts of relational data would be nearly impossible. But how do we categorize these diverse functions? To grasp SQL's capabilities, we categorize its commands. So we have the DDL, or the data definition language, for creating and modifying database structures. We also have the data manipulation language, or DML, which handles interactions with actual data records. The data control language, on the other hand, or DCL, manages security and user access. And finally, the TCL, or transaction control language, ensures data integrity during actual operations. So for this session, we'll focus on DDL and DML as they form the core of the daily database interactions. So these categories are implemented across various database systems. And to go through, let's try to look at some of those systems now. So while SQL is a standard, it's implemented across various database systems, each with unique strength are presented in here. MySQL, for instance, is a popular open source choice for web applications, while PostgreSQL is known for its advanced features and strict compliance to SQL, of course, favored for complex data environments. It is in fact gaining popularity nowadays if you have read some articles related to PostgreSQL. Now, Oracle databases is a enterprise-grade solution. It's highly scalable for large corporations, and it's very known to be one of the dominant database systems for large or corporate environments. MS SQL or Microsoft's SQL Server integrates seamlessly with the Microsoft's ecosystem, and it's widely used for business intelligence. While our SQLite is a lightweight embedded database, perfect for local application storage. Now, there are a lot more query-based databases, like for instance, IBM DB2 is also one of the competitor here, MariaDB if you have heard it, and a lot more databases, in fact, could actually be used for querying. Now, let's dive into the specifics of DDL. DDL, or the data definition language, is how we build and shape the very foundation of our databases. It's the architectural blueprint for our data. So from the list here, we use create to bring new database objects into existence, like the table or indexes. In fact, the database itself. Now, if we need to adjust that structure, perhaps adding a new column to a table, then we could make use of alter as our command. And when an object is no longer needed, like a table, you would want to remove it, we can actually use drop, entirely removing it in the database. And truncate offers a quick way to clear all data from the table while keeping its structure intact, which is a key distinction from the delete. Now, I would just like to iterate. Drop removes the entirety of an object, be it a database or a table, while truncate only clears the data within a certain table, but still keeps the structure of our table. So, wala nga lang laman na wala tayong makikitang record pero buo pa rin yung table schema natin, or yung pag dinescribe natin siya, makikita pa rin natin yung structure ng table natin. Yeah. So, here are a few of the commands associated with, or SQL statements associated with create, like create table for creating new table with specified columns and data types, the sequence to generate unique numbers, index to improve query performance, create view for virtual table, and then create synonym, like putting an alias to a table, or create materialized view. More often than that, we normally don't see sequence, synonyms, and materialized view as a usual practice in creating objects in tables, but they actually are also usable in terms of using create as a command in the DDL category. Alter, for instance, modifies existing table by adding, dropping, and modifying columns. So if we could actually create sequence, index, view, synonym, and materialized view, we can also modify it through alter command. Drop, as I've said a while back, deletes the structure and the entire data associated in that structure. No? So if you have created an object a while back, we can modify it through alter. Then we can also drop it. Okay. Then rename is a statement that we could actually use to rename an existing table. So DDL statements are typically executed in a separate SQL window or script rather than within PLSQL blocks. It can affect multiple objects at once, so it's important to be very cautious when executing them. For instance, you made use of drop database, and then you press the enter key in your console, and you don't realize the entirety of the database tables were already being erased as part of the system. Now, DDL statements are not transactional, meaning they cannot be rolled back if an error occurs. So it is recommended to use a backup strategy to protect our database from accidental data loss. So by understanding and effectively using DDL statements in PL/SQL, in fact, in any other query-based databases, you can create, modify, and manage your database objects efficiently and ensure data integrity. Let's dive our let's dive into DML. Now that we have defined our database structure with DDL, data manipulation language or DML allows us to interact with the actual data inside. This is where most of our daily database work happens. So select is our primary tool for retrieving information, allowing us to pull specific data based on our needs, while insert lets us add new records, populating our tables with fresh data. When data needs to be changed, we can make use of update, modifying existing entries specifically, and delete removes records that are no longer relevant. But these commands under DML are the core of how we manage the dynamic content of our database. Before I forget, you could actually make use of merge, call, explain, plan, and lock table within the context of manipulating the data within our table or database tables. Beyond the core DML commands, SQL provides a rich set of operators and functions to refine our data manipulation. So these operators are not new to you anymore because they've been used in many programming related courses and in our early mathematics courses. Now, so comparison operators such as equals, greater than, less than, less than or equal, or greater than equal, and not equal are fundamental for filtering data in the where clause, particularly used with the select or it, update or any other DML commands. Logical operators like and, or, and not allows us to combine these conditions, building a complex criteria for data retrieval. Before I forget, let's recall of the wildcards associated with select or select command. So we could actually make use of the ampersand or the person style to represent our search queries. Later, we could actually make use of those within our exercises. Now, special operators including between for range checks, like for pattern matching, in for list comparison, and is null for handling missing data offer even more granular control. Finally, our aggregate functions are indispensable for summarizing data, allowing us to calculate counts, sums, averages, maximums, and minimums across groups of rows, I should say, providing valuable insights from our data sets. So these aggregate functions again, are not new to us anymore since we made use of these in the Excel as part of manipulating data within spreadsheets. Now, let's elevate our SQL skills with advanced querying techniques. So, we're moving beyond basic DML operations to truly unlock data insights. So, ito yung mga mostly ginagamit natin for data science approaches or data analytics already. Though we might not see these queries working within our vivid eyes, but when we try to associate them with manipulating data in terms of in data analytics concept, ito yung mostly ginagamit natin to operate them. No? So one of the most powerful features is join operations, which allow us to combine data from multiple tables based on their relationships. Now we have inner join for exact matches. We have left join to include all records from the left table and right join from all records from the right, and full join to get all records when there's a match in either table. No? Subqueries or nested queries enable us to use the result of one query as input for another, providing immense flexibility in data retrieval. Furthermore, aggregate functions like our count, our sum, max, average, minimum allow us to perform calculations of groups of data, which we define using the group by clause, and then filter these groups using the having clause. No? So this is how we start to ask more complex questions of our data using advanced SQL queries. Now, let's continue exploring more advanced techniques. Building on our advanced query techniques a while back, window functions offer even more sophisticated analytical power. Unlike aggregate functions that collapse rows, Windows functions perform calculations across a set of related rows without losing individual row detail. Now, think of them for ranking or calculating running totals. And a list of an example is in the screen. Common table expressions or CTEs are another excellent tool for improving query readability and simplifying complex logic. They let us define temporary named result sets that we can reference within a single query. And finally, stored procedures and functions are pre-compiled SQL codes stored in that database, enhancing performance, reusability, and security for frequently executed operations. So these tools I've mentioned here are crucial for optimizing and managing complex database interactions. Now, let's wrap up some key takeaways and open the floor for inquiries. Though in the next few slides, I'll be asking you to do some sort of recalling your DML commands and DDL commands by way of creating a table, adding or inserting data to those, and then manipulating them thereafter. Now, so in summary, SQL remains the indispensable language for managing relational databases. So we tried to explore on how DDL defines a database structure, while DML allows us to manipulate the data within it. So mastering our advanced queries, including joins, subqueries, and window functions, actually empowers us to extract deep and better insights. So now looking ahead, SQL continues to evolve, integrating with NoSQL databases and moving towards cloud native services, often with AI and machine learning for enhanced optimization. So I hope that this session at least reinvigorated our clear understanding of SQL's enduring importance in our role to maintain and advance data management. Now, in this point in time, I would like that you visit and create a account, Oracle account at freesql.com. You will be redirected to your own schema. Okay. And then from that, you are to create tables with the fields below, explicitly including the fields and applying an appropriate parameters to all of those. So we have table students with student ID as a primary key, inclusive of the field last name, first name, middle name, sex, date of birth, and province ID as a foreign key. The province table will include province ID, the province name, and the zip code, while the table courses includes a primary key, course ID, course name, course unit, course status, course requisite. At the professor's table, prof ID is assigned as primary key, including last name, first name, M name or middle name, and the job title to complete that table. Now, the enrollment there will only focus on courses enrolled. What are the courses enrolled? Who are their teachers in those courses? And then the student enrolled to those courses within that professor. Now, and then at table grades, we'll be able to extract in the courses enrolled, the prof, the student ID, the grades, and then some remarks to those. And then table work, referring to the student's current workplace or work-related data of the students, not the professor, okay? That the job title, their company name, the job role, and to where they're actually from in terms of their zip codes. Okay. So at least populate the schema with at least 30 students from the 5 provinces of Region 2. At least 1 male and female. And courses include the current MSIT courses and professors. Now, integer grades assumed for at least 4 subjects completed ranges from 88 to 100. Others left blank or INC or IP. Okay, so just to give you a clarity to item number 3. Now you will have to use insert into command or insert command to populate the table, particularly the students table and the province table, covering the 5 provinces and the students coming from the different provinces in the region, and of course, to which town or zip code they are representing. No, and then courses. I mean the subjects include that the four subjects you are actually taking now, and assign professors to those. Now, populate also courses. I mean, grades table, considering or assuming that at least four subjects already has been completed by some or if not all of the students, and then with a assigned grade between 88 to 100. Some may be left blank because they're currently taking it. So nakalagay doon in progress. Or if assuming natapos siya na pero wala pa siyang grade, assume putting it with INC. Okay. Now, provide SQL queries and outputs for the following questions. Now, after you're done populating the tables, now you can now answer A to E here. I think meron pa tayong susunod. Yeah. So first one is how many male students from Cagayan province obtained a average grade higher than 93? So regardless of the data you actually included there, I would be able to determine through your correct SQL statements. Now, letter B, which students performed well in each of the four subjects taken? Arrange them accordingly. So you'll be making use of an order by here, where you will be able to determine which student got the highest grade in the four subjects. Each in the four subjects already taken. Now modify the grades of female students from Vizcaya and Batanes who first obtained 88 in all their courses into 90. So again, meron tayong condition dito. Female coming from Vizcaya and Batanes whose initial grade is 88. And in any courses they actually took and then assign it with the grade 90. Okay. Letter D. What are the job roles of the students working and obtained grades lower than 93? Which of these students who are actually working, because some others may not be working, or yeah, and have obtained a grade lower than 93? Okay? So, depende po yan sa pinopulate yung data. I mean, table doon sa data. Yung data na nilagyan natin sa table. But I will be able to determine which of these actually work based on your queries. Now, who among the students are enrolled in at least four courses that are working and is more than 25 years of age? So, makakaalaman yan dun sa query statement natin. Now, download the copy of the editor content as attachment to the answers in item in item 4, referring to A, B, C, D, E. Then towards the end of your answer sheet, do a reflection of the activity. What aspects do you find challenging? Which aspects you will need to improve, and put them in the answer sheet before submitting the same as a PDF directly to my email. Okay, so I think that would be all, and thank you. Yeah. Stop. recording.